Welcome to the 4.5 video. Today we're going to continue to work with quadratic functions and specifically learn how to solve quadratic equations. So we're going to have a goal of solving quadratic equations by factoring as well as by graphing. So let's begin by talking about what a zero is. Wherever the graph of f of x intersects the x-axis, the value of f of x, or y, is equal to 0. So the value of x when f of x is equal to 0 is called a zero of the function. So take a look at the graph at right. The points right here that are drawn, that are intersecting the graph at the x-axis, are called the zero. So in this case, the zeros for this function would be x equals positive 3 and x equals positive 6. If we are given an equation and we want to find the zeros, what we need to do is set the equation equal to 0 and then solve for x. And in order to do that, we're going to be using something called the zero product property. It says if we are multiplying two numbers, a and b, and the product equals 0, then one of the numbers, a or b, must equal 0 in order to make the product equal to 0. So let's begin by taking a look at example 1. Here in example 1, we are given the quadratic equation x squared minus 5x plus 6 equals 0. We need to figure out the solutions, or the zeros, of this quadratic equation. So please take a look at the invisible leading coefficient of positive 1. Because we have a leading coefficient of positive 1, we know that we can go straight to the x method to solve. So we're going to take the last number, which is 6, put it on top, and the middle number, which is negative 5, put it on bottom. We need to figure out two numbers that multiply to give you positive 6, but add to give you negative 5. So if we're multiplying to get a positive, the signs of the factors must be both positive or both negative. But if we're adding to get a negative, then that means the signs must be both negative. The two numbers that work for this situation are negative 2 and negative 3. Because when you multiply negative 2 and negative 3, you get positive 6, but when you add those two numbers, you get negative 5. So to write this in factored form, we want to write x minus 2 times x minus 3, and that equals 0. In this case, we already have 0 on the right side, so we don't need to make it 0. But in future situations, we may need to add or subtract by whatever number is on the right side in order to make it 0, and then solve from there. So using the zero product property, we want to set both of these factors equal to 0, and then just do one step each to get the solutions of the zeros. So we want to add 2 here, and we get x equals 2. And we want to add 3 in the other equation to get x equals 3. So the two solutions, or the zeros, of this quadratic are x equals 2 or x equals 3. And please remember that the solutions of a quadratic equation, or the zeros, are where the parabola is crossing the x-axis. In example 2, we are given the quadratic equation 5x squared plus 30x plus 14 is equal to 2 minus 2x. We need to figure out the solutions of this quadratic equation, and I'm going to show you the process dealing with tables. So before we do anything else, let's make sure we have 0 on the right side of the equation. So I'm going to rewrite the original and then do the opposite to make sure I have 0 on the right side. So the first thing I'm going to do is add 2x to both sides and make sure you line up the like terms. And we get 5x squared plus 32x plus 14 is equal to 2. One more thing, subtract 2, and again line up the like terms. We get 5x squared plus 32x plus 12 is equal to 0. So now we have it in a nice format, and we can use the table feature on our graphing calculator. So pull out your graphing calculator, turn it on, and go to the y equals. If there are any functions in here, make sure you clear them. And now let's type in our equation that we just solved for. So 5x squared plus 32x plus 12. Once you have this entered in for y1, we want to go to the table, which is located right here. So we want to go to second table. And what we want to do is look for x values for which y is equal to 0. Now, we're not actually finding a y value of 0, but take a look right here. These two values for x, negative 1 and 0 respectively. The y values are negative 15 and 12. Well, 0 would be between those two values. So that means one of the zeros is between negative 1 and 0. In a moment, we're going to figure out the exact solution, but first I want to look for the other one. Oh, right here we have negative 6 for the x and y is equal to 0. So one of the zeros is negative 6. Now we're going to search for the other zero that's between negative 1 and 0. So I'm going to take a look. I'm actually going to test out values that are very small negatives going up by zero point 0.1. So I'm changing the x interval to go up by 0.1. So I'm going to type in negative 0.8. So you may have noticed that it wasn't letting me replace my input values. Maybe it's working on your calculator, and that'd be great if it was. So if you're running into the same issue as I am, you want to go to second table set right here. So you're essentially pressing the window button, second table set, and you can see the change in each of the input values is a default of 1. So now we're going to change it to 0.1. Make sure that you remember to go back after this problem and change it back to the default of positive 1. So now let's go to the second table again, and you can see that the input values are increasing by 0.1. So we're going to get a more precise idea of where the 0 would be. And you can see that the y values are getting closer to 0. And we finally found the other solution, which would be x equals negative 0.4. So that means the quadratic equation intersects the x-axis at the two x values of negative 0.4 and negative 6. In example 3, we're given the quadratic equation 2x squared plus 7x equals 15. We need to solve or get these solutions or zeros of this quadratic equation. And instead of using the table method, we're going to actually be using the graphing process. And in my opinion, this is the better way to go. So before we do anything, we want to make sure we have 0 on one side of the equation. Currently we do not. But for this problem, we only have one step to make sure that's a 0. And the way that we do that is subtract 15 because that originally was a positive 15 over there. So now we have 2x squared plus 7x minus 15 equals 0. Now what you want to do is go to your calculator and go to y equals. We can get rid of the previous function that we just worked with. And now let's type in our new function, which is 2x squared plus 7x minus 15. Now let's go to our trace feature. You can see that I still have some data points from a previous lesson video, and you may as well. So let's go to second stat plot and turn the stat plot off so we don't see those points. And you can also notice that the parabola, only half of it or just a portion of it is showing, so we need to change our window. So let's see if zoom fit will work. Okay, that's a little bit better, but I still want to see the other 0 because currently we only see 1. So I'm going to change the x value to be negative 50 and the x, let's see if that works. Okay, so we basically see both of the zeros now. And then let's see if we can zoom in and still see them. Okay, that's a much better picture. Okay, so now I'm going to teach you how to use the 0 option in the calc category. So we've been here before, so go to second calc, and we've used the minimum and the maximum and the intersect before. Now we're going to be using the 0 button, which is number 2. So press enter, and then now you want to we're actually going to have to do this twice. So left bound, which means it's going to be on the left side of the parabola and the 0. So press enter, and then now go below or the right side of that 0, press enter, and then guess. And you can see that our first 0 is at the coordinate point x equals negative 5, y equals 0. Now let's find the other 0. So you want to go back to second calc, down to 0, press enter, and now let's arrow over to the left bound or the left side of the 0, so somewhere around there, press enter. Now go above to the right side of that 0, press enter one more time, and now we get the other 0 of x equals 1.5. So we just did a factoring problem, a table problem, and a graphing problem. In the last example for this lesson, we're going to be using the graphing process as well as a couple other processes to figure out a real world problem. Here's example 4. From the time Mark Twain wrote The Celebrated Jumping Frog of Calaveras County in 1865, frog jumping competitions have been growing in popularity. The graph shows a function modeling the height of one frog's jump, where x is the distance in feet from the jump's start. So take a couple seconds to look at that frog jumping and notice that that is a parabolic curve, aka is forming a parabola. And we are told the equation of this frog's jump path, and that is y equals negative 0.029x squared plus 0.59x. So first thing we want to do is figure out how far did this frog jump. We're going to be using our graphing calculator to assist us in this process. So let's go to our graphing calculator, go to y equals, clear out the previous function, and now type in the new one. We want to graph this function and locate the point where the graph crosses the x-axis. That's going to determine how far did the frog jump. So let's go to our trace. So you probably noticed that I wasn't really able to see the path of the frog in that previous window. So I just spent a couple seconds right now kind of testing out different x values for the domain and range for the window. So this set of mins and max work really well. So you can feel free to use the same ones that I'm using. -5, 25 for x min and x max, and then for y min and y max I have -5 and +10. Now let's go to the trace feature, and you can see the parabolic curve of the frog's jump. And we want to use the 0 feature that we used in the previous example. So we want to go to second calc and then go down to 0. And we don't need to worry about this left 0 because we know that the start point for the frog is at 0, 0. So we just need to worry about this other one. And we want to choose a point above or to the left of the 0 and then one below or to the right of the 0. And it gives us a value of approximately 20.34. So that would be the distance in feet of the frog's jump. So now that we know the distance of the frog's jump, we need to figure out how high did the frog jump. So taking a look at this original graph that we were given, we now know that this distance right here is approximately 20.34 feet. So if we're trying to figure out how high did the frog jump, we actually need to figure out the vertex coordinate. So that would be approximately right here. That would be the maximum height of the frog. And the height of that frog is going to be matching with the x value of halfway in between. So halfway of 20.34 feet would be 10.17 feet. So now we know the x value, and in order to get the y value, the max value, we just need to plug 10.17 in for the equation that we're given. After substituting in the x coordinate of 10.17 in for the x values for the original function, I got a y approximately 3. So that means when the frog was halfway in between the starting point and the ending point, which was at 10.17 feet, the frog jumped to a height of about 3 feet. So at this point right here, the frog hit its max height of 3 feet. And in part C, what we want to do is figure out a reasonable domain and range for such a frog jumping function. As we discussed in previous lesson videos, parabolas typically have a domain that includes all real numbers, but in this particular situation, actual frog jumping does not allow for negative values. So a reasonable domain for this frog jumping distance would be 0 is less than or equal to x, which is less than or equal to 30, which means x can be between 0 and 30. The reason why I picked a number such as 30 is because it could include values that were beyond this max distance or jumping distance of 20.34 feet. So there could be frogs that could beat this frog's distance. For the range, a reasonable range would be 0 to 5. So 0 is less than or equal to y, which is less than or equal to 5. And I did include a couple extra feet just in case there was a frog that could jump a little bit higher than this frog. So that completes our real life example. And now we just need to do the lesson check problems. So make sure you write down all 5 of these problems. I do want you to try all of them so we get maximum practice. And please let me know if you have any questions on today's lesson when we see each other next.